Hello ladies and gentle ladies, and welcome back to another Minecraft modding tutorial for 1.21 in Fabric. And in this tutorial we're going to be creating a ticking block entity. So in the previous tutorials we created a basic block entity, and we are going to be extending off of that in this tutorial to allow it to tick and do some exciting logic. So that tutorial will be a requirement for this tutorial. We are not going to be covering how to set up a block entity or how to create it or what anything does, because we've already gone through that in the previous tutorial. So you need to make sure you have watched that one first. So I've gone ahead and created a very basic block and block entity here. So I've gone ahead and just created a ticking block that implements our provider, of course, and does this. And then on use, all I'm doing is I am sending a message saying we are mining at a specific pos, and you see in my block entity class I've just got an int for ticks, and then I've also got a block pos which is the mining pos, and by default I'm setting that to the pos below, and then I'm just saving and reading both of those things. So nothing special. All of this we've gone through before. So what is this block entity going to do, first of all? So effectively it's going to work as a quarry. So basically all of the blocks below it, it will just mine them one by one, and it will drop the items on top of the block. However, if there's a chest on top of the block, then we want it to insert those items into the chest. So fairly basic, but also quite cool. So how do we do this? Well, we need to make it tick. And how do we make it tick? Well, we do that inside of our block class. So this block entity provider interface here gives us a method called getTicker, and that allows us to provide a method that we will use for ticking. So funnily enough, you can actually choose to tick it wherever you want. It doesn't matter. It doesn't actually have to be in the block entity class itself. You could have your tick method in the block class. Now, I don't recommend that you do that. I always recommend you have it in your block entity class, but that is just something to note, and you'll see why in a second. So what we're going to do is we are going to override our getTicker method, and in here, as I say, you can return your method that will tick. Now, I do see some people like to make this method static, and so you would be able to do something like example ticking block entity dot tick, and you could pass in all of these little things here. But we're not going to be doing that. We are actually going to create an interface that will implement on our block entity, and then we can override a tick method, and then all we have to do inside of this ticker is return that tick method, basically, if it's an instance of our tickable interface. And that just allows for a lot more reusability in the future if we ever want to create any other block entities. So what I'm going to do is I'm going to come into our main package, and I'm going to create a new package, and I'm going to call this util. And inside of here, just for future reference, we're going to be just adding some utility based classes. This one specifically is going to be an interface, and we're going to call this tickable block entity. In here, we're just going to want a void tick method, and then we are also going to want a static method as well. So this will be static, and this method will also be generic. So we're going to say t extends block entity, and then we are going to return a block entity ticker of type t. So if we come into this block entity ticker class, you will see that it has a tick function. So effectively, this is a functional interface, as it says there, and you need to provide a function that takes in all of these parameters. So effectively, that's what we're going to do, but we're going to make it a little simpler for ourselves so that our tick method doesn't have to take in all of those parameters, because those will automatically all be available to us from our block entity class anyways. So we can just call this method getTicker. So this method does not need any parameters at all, and all we need to do is return, and then we're just going to automatically use this autocomplete here to generate our parameters there. And then inside of the lambda body, we're just going to check if block entity is instance of, and we're going to check if it's instance of this class. So we can check if it's instance of a tickable block entity, and I'm just going to call this a tickable block entity. If it is, all we're going to do is we're going to say tickable block entity dot tick. So a fairly simple class. So inside of our block, all we need to do inside of this getTicker method is return tickable block entity dot getTicker. And that is it. Our block will now go ahead and tick. Now, one thing I should state is that this means it will tick on both the server side and the client side. So if you want that, then that is fine. However, if you don't want that, then you'll need to add an additional check in here to say whether or not it should check if we're on the client or not. And if we don't want it to tick on the client side, then ideally we don't even have this actual ticker at all. We just have a null block entity ticker, so it just won't tick at all on the client. So how do we do that? Well, you'll see that we can't access this world outside of this because it's inside of this lambda effectively. So we can't use it outside. So what we can do is pass in a world parameter. So I'm going to call world. And we can't actually call this world because that will conflict with this world here. So since this is a parameter, and this is kind of more of a C++ convention, but we can use it in Java too, it's not that big of a deal, I'm just going to call this p world. So it just indicates that this is coming from the parameters instead of just inside the actual method body as a local variable. It doesn't really matter what you call it. Of course, you could call this world and call this world1. That's perfectly fine too, but I think this is just a little more descriptive. And then we can just say pworld.isClient. If it's client, we can just use null, or we can use our ticker here. So we're just using a very basic ternary statement to indicate that if we're on the client side, we're just going to give a null ticker because we don't want it to tick on the client side. And that's how I'm going to go ahead and leave it, because I don't want to ever basically create a block entity that will tick on the client side. In the future, when we do want that, we can create an overload for this method and we can go ahead and deal with that then. But for now, this is going to be perfectly fine. So now that we have done that, we do need to obviously pass in the world, which we can get from our parameters here. You'll see that if you wanted, you could also do something dependent on the state of the block and also the block entity type as well. So you do have a little bit of flexibility with how you define whether or not this block should tick. For example, on a certain state, you might not want it to tick. And so you would say if the state is, some certain state, then you're just not going to provide a ticker. You're just going to give it null. Else you might want to actually tick. So we are now done with that class, and we are also going to be done with our block class completely. So we can now move on to our actual block entity class. So how do we make the tick method? Well, all we need to do is go ahead and implement that interface. So we just need to say implements tickable block entity. And then you'll see it's going to give an error because we need to implement the methods. So I'm just going to override the tick method. There we go. And what I will do in here, which is generally recommended, is to check that the world is server side regardless. So you might want to just say if, and we're first going to check if it's null. So if this.world is null, or this.world.isClient, then we're just going to go ahead and returns, because we don't want to do any of the logic that we're going to do if either of these are the case. Then we are going to go ahead and say every second we're going to go ahead and mine a block down. So how do we do that? So from this point onwards, by the way, for this tutorial, this is just going to be coding the actual logic for the block entity. We are now done with ticking. You can obviously do whatever logic in here you want, but I'm just going to show you how to do the specific logic that I want to do, because you might also learn something new specifically about interacting with inventories that are above us. So how do we go ahead and do all of this? Well, I want it to go ahead and only mine down every second. So the easiest way to do that is just say if this.ticks ++, because we want to increment it, and we're going to say modulo 20, which means it will basically divide that number by 20 and then return the remainder. If that is equal to 0, so effectively if it's a multiple of 20, then we are going to go ahead and continue. And the reason we are saying 20 is because, if you don't know, there are 20 ticks per second in Minecraft. So if this is the case, we want to go ahead and actually mine down. But the first thing I'm going to do is check if we're below the bottom of the world, because if we're below the bottom, then we're going to want to restart from the top so that we don't try and mine all the way infinitely down. So a very basic check we can do here is if this .miningpos.getY is going to be less than or equal to this .world.bottomY, then we can just set this .miningpos to be this .pos.down, which will go ahead and reset that if we ever reach the bottom of the world, which is fairly self-explanatory. The next thing we're going to go ahead and do is get the block state, because we want to check if it's air or if it's unbreakable. Then we're just going to go ahead and skip that block completely. We don't want to have to go ahead and deal with that. So all we're going to say is we're going to say block state, and we're going to set that equal to this .world.getBlockState, and we're going to say from this .miningpos. So if you're unaware, a block state is effectively just the state of a block, so the current state, and that is with all of the specific properties that it might have. For example, a furnace has loads of different states. You have, for example, whether the furnace is lit, and that could be on or off, and then you also have the facing states of the furnace. So you have if it's facing north, south, east, or west, and then you have a combination of those as well. So effectively that is the block state, but also from the block state you can get the block, and you can also get the hardness as well. So the state is actually super useful to be able to obtain, because we can call a load of different methods on it. So for example, we can say if state is air, or the state.getHardness, and we can pass in the world, so this .world and this .miningpos. If the hardness is less than 0, so if it's unbreakable, or this block is air, then all we're going to do is say this .miningpos is going to be equal to this .miningpos.down. So that will just say if either of these cases are true, then we're just going to go ahead and move down a block, and then you can either proceed if you wanted to do that. I don't want to do that. I just want to go ahead and return. So we're going to completely skip that specific tick. And the reason I'm doing that is because we don't want to go ahead and try and get the drops for like an air block or a bedrock or something like that, because that would just be computationally expensive for effectively no reason, and also you could end up getting an item that you don't really want to get. So we just want to go ahead and skip those blocks completely to avoid any special edge cases where things could go wrong there. So then we can go ahead and actually get the drops from that block. Now this is actually a little bit complicated to do. There isn't a direct way to just say get drops, right, and that returns a list. You do have to actually build a loot context effectively, and then you can pass in the specific details about how you should obtain those drops. So it is actually quite cool and very customizable, so I will show you that now. So all we're going to do is define a list of item stack, and I'm just going to call this drops. And what I'm going to do is I'm going to set this to state. So we're going to use our block state again, and we're going to say get dropped stacks. Now this needs to take in the builder. So what we're going to do is we're going to give it a new loot context parameter set dot builder. Inside of this, we need to pass in a server world that can be used to construct this builder. And I'm just going to go ahead and cast our world to a server world there. And the reason I know that we can fairly safely do that is because you see here that we are checking if we're on the server side. So it's not ideal because we're not doing an instance of check. However, there is basically a pretty much certainty that we are going to be in a server world because it's not a client world. So it basically has to be a server world. Then what we need to go ahead and do is add some parameters to this. So the two required parameters that you need is the tool that is being used to mine the block, and then also the origin position of where basically it's being mined. So what we can do is say .add, and we can add loot context parameters, and you can choose to add any different parameters in here that you want. But we're going to do the required ones first. So we're going to pass in the tool, and for the tool, I'm just going to give mine a diamond pickaxe, but you can choose whatever tool you want. And do note that the drops are probably going to be different depending on the item you provide it. So for example, if you gave it a pickaxe that was enchanted with silk touch, then your drops would probably have silk touch. So they would be a silk touched drop. But we're just going to have a normal diamond pickaxe. So all I'm going to say is items.diamondpickaxe.get default stack, and that'll just get that as an item stack. Then we can add the position of the block that's being mined. So I can add loot context parameters.origin, and I can pass in this.miningpos. However, this needs a vec3d, so we need to go ahead and say .toCenterPos, which will get that into a vec3d. So it basically gets the center position of that block. Then finally, you can add any optional parameters that you want to add. And I am actually going to add one here. I'm going to add loot context parameters.blockEntity, and I'm just going to pass in this, which just tells it that it has been mined from a block entity. If for some reason there was a loot table that said if it's mined by a block entity, then drop something different, then that helps to identify it in that way. Now this will get us a list of drops, however we are not sure whether or not this list is mutable or not, and we are going to need it to be mutable, and so I'm going to just go ahead and copy that, constructing it with a new array list. Then what I'm going to do is I'm going to go ahead and break the block. So I'm simply just going to use this.world.breakBlock, and I'm going to pass in the position. So I'm going to go ahead and use this.mining position, and we're going to say whether or not it should drop. Now we don't want it to drop because we actually are getting the drops ourselves, so we can go ahead and just say false. And then you'll see here that you can also provide an entity and also a max update depth if you want to. We're not going to worry about those since we don't have an entity to give it, since this is being mined from the block entity. Now from here, you can go ahead and spawn the drops on top of the block if you want. However, I would like to say if there's a storage above, so if there's a chest, for example, then we want to try and insert our drops into that chest first. Obviously, if the chest is full and it can't take the item, then we want to go ahead and spawn it on top. So how do we do this? Well, luckily with Fabric, this is actually very, very simple. So what we can say is storage, and this is of type item variant. So we are expecting to receive a storage that will have item variants inside of it. I'm going to call this above storage, and I'm going to set this equal to find item storage, which is a method we're going to create in a second. We're going to pass in the world, and this needs to be a server world. So I'm going to pass in server world, this.world, and then I'm going to pass in the position above. So effectively, that's the position that we want to try and find the storage from, and that'll be the above position of the block entity. Then all we need to say is if the storage is not null, so if above storage is not null, and the above storage supports insertion, since we want to check that we can actually insert into this storage before we try and insert into it. So if it's not null and it supports insertion, then we're going to want to insert our drop. So I'm going to create another method for this. I'm going to call it insert drops, which will pass in our drops, and then it's also going to pass in the storage that it should insert them into. After that, I'm going to go ahead and spawn any drops that are left over. So all I'm going to say is if the drops is not empty, then I'm just going to say spawn drops. I'm going to pass in the drops. I'm going to pass in the server world, which will need to be casted again, and then I'm going to pass in the position. Finally, all we're going to do is say this.miningpos is equal this.miningpos.down, so that we go ahead and go down a position. Okay, so let's go ahead and create these methods. All of these are going to be relatively simple. So let's create the find item storage first. So I'm going to create a private static storage of type item variant, and we're going to call this find item storage, which is going to take in a server world, and then it's also going to take in a position, so a block pos pos. All you need to do in this method is return item sided, is return item storage dot sided, and all you need to say is find. That needs to take in the world, then it needs to take in the position, then it needs to take in the side that we're trying to insert from. So the side that we're going to be inserting from is going to be from the bottom. So the direction would be direction dot down. If you, for example, wanted the chest to be on the bottom, then the direction would be direction dot up. So you're looking for a storage that will effectively accept it from the opposite direction that it is relative to your block, if that makes any sense. Next, we are going to create a method to go ahead and spawn the drops, and we're going to do this one first just because it's a little bit simpler. So we're going to say a private static void spawn drops. This is going to take in a list of type item stack, and I'm going to call this the drops. Then it's going to take in the server world, which will be the world, and then it's going to take in a block pos, which is the position. Then we're just going to loop over the drop. So we're going to say drops.for for drop in drops. We're going to call item scatterer, which is a vanilla class, and we're going to call dot spawn. We're going to pass in the world, and then we're going to pass in the X, Y, and Z coordinates. So I'm going to say pos.x, and I'm going to add 0.5 so that we're in the middle of the block, and then we're going to do the y position, which will be pos.getY, and I'm going to add 1 so that we are just one block above, and then I'm going to add pos.z, and I'm once again going to add 0.1. Then finally we need to obviously pass in the stack as the final parameter. Okay, the final method that we need to go ahead and create is our insert drops method, which will insert the items into the actual storage. So I'm going to create a, once again, private static void insert drops. This is going to pass in a list of item stack, which is the drops. Then it is going to pass in the actual storage, so a storage of type item variant, which is going to be the above storage. In this method, we are once again going to loop over the drop, so we'll say drops.for, so for drop in drops. Then we are going to create a transaction. So we are going to try, and we're going to create a transaction. Transaction is going to be equal to transaction.openOuter. So what this will go ahead and do is create a transaction that we're going to use to insert into the storage. So effectively, the way that Fabric works is it requires that to be able to insert, you need to create a transaction, and then you can go ahead, when you're done, you can either commit the transaction, so it actually happens, or you can abort the transaction, which means that actually it will have simulated the transaction and it won't have actually happened, which is super useful. So if you're coming from Forge, think of the insert method where you try to insert an item stack maybe into an inventory, but there is the boolean at the end of the insert method, which is whether or not to simulate. This is effectively the same thing, but with transactions. So you create a transaction, and if you go ahead and actually commit the transaction, then it will actually do it. If you don't commit the transaction, or you choose to manually abort the transaction, then it will go ahead and basically simulate the actual transaction. You'll see here in the examples, it also says you can open nested transactions. So you might want to commit a nested transaction, but abort the outer transaction, which would then go ahead and actually abort the nested one as well, even though you committed it. Or you might want to abort the nested one, but still commit the outer one, that kind of thing. It allows for a lot of flexibility. So what we're going to say is we're going to say long inserted, and we're going to set this equal to the above storage dot insert. We're going to insert first the item variant, and the way we get that is by saying item variant dot of, and we're just going to pass in the stack, which is the drop. Then we're going to pass in the max amount, which is going to be the count of the drop. So this is basically the maximum amount that it should try and insert. And then finally, we just pass in our transaction. Then what we're going to go ahead and do is we're going to say if inserted is greater than 0, then we're going to say drop.decrement, and we're going to take in the amount that it inserted, which we have to cast to an integer since it's a long here. And then we can go ahead and actually commit the transaction. Now, if the inserted is greater than 0, what this will do is it will go ahead and close the transaction, which will then go ahead and abort it. So this is effectively the same as saying else transaction.abort. However, by not specifying, it will just abort manually because we haven't committed the transaction. Then all we're going to do after this whole entire for loop is we're going to say drops.removeIf, and we're just going to pass in a predicate that will define if the item stack is empty, we're just going to remove it from the list. And that means that we don't have to then deal with empty item stacks when we get into our spawning method, if that happens to happen. So all we need to say is item stack is empty. Okay, so that should be everything. All we need to do now is go ahead and run the client. Obviously, make sure you've done your data gen as well. Make sure you've initialized your block, registered your block entity as well, and all of those shenanigans. And once you've done that, you can go ahead and run your client, and we should be able to see if everything works. So if we go ahead and place down our block entity here, you'll see that it mines the blocks below and it starts dropping them. And you'll see that it is actually mining down, and it should be once every second, ideally. Now, if we go ahead and put a chest on top, so let's grab a chest. And if we place that on top, you should see that the items are now getting inserted directly into the chest from the drops that are down there. And you should be able to see when it reaches, for example, ores, it will go ahead and mine the ores and all those kind of things, which is super duper duper cool. And you see that is there working. And obviously you could make this a double chest as well, because the way that chests work is that when they're combined like this, they function as a single storage, which is super cool. So that means that it will even start inserting into this area here if this was to fill up. Now, if we come down here and actually see what it's doing, and you'll see it is mining the blocks. Now, let's see if we can see what happens, for example, when it reaches an ore maybe, or if it reaches bedrock. So we can go ahead and watch what will happen if that is the case. You'll see it has actually found diamonds here, but it hasn't been able to mine them since it's not actually in the path. Now, you could obviously alter the algorithm to say if there is an ore on any of the adjacent blocks, then it might go ahead and vein out and mine that whole ore vein, which would actually be super cool if you did something like that. I don't think anyone's actually done that before, so that's a free idea if anyone wants that. You see, once again, it has narrowly missed 2 diamonds. That is actually crazy unlucky there. And it's also missed 2 redstone. We're not getting very lucky here, but you'll see that it has now gone ahead and reached bedrock. And we go ahead and right click the block. You'll see that the position it's currently at is Y53. And every second that is going to go ahead and decrease. And obviously that's not actually going to mine anything now because all of the blocks are now air, but obviously it doesn't know that, so it's going to go down and mine. When it reaches the bottom, it'll reset and then go back down and down and down again. So obviously this isn't a super useful quarry. You would want to be able to, for example, maybe supply specific dimensions, or supply maybe an enchantment to use, or you might supply upgrades as well. You could do all these cool things with it. Think of just a quarry, all of the cool things you could add to it. I'm thinking we might extend this in the future tutorials rather than creating a whole new block every block entity tutorial. We might just go ahead and extend this. I'm not sure. For now, I'm going to leave it as it is, of course, because I think that is it for this tutorial. Obviously, I hope you guys found it useful, and if you did, please do be sure to give it a like and subscribe. By the way, I did intend to do the entity tutorial today because I know that it has been strongly requested, but I just didn't have time to be able to record it and then edit it and then upload it before the deadline tonight. But we will do them, I promise. We will go ahead and get around to entities. Basically, as soon as I can get the test mod working for entities, I will go ahead and then record the actual video of them as well. But yeah, I will see you guys in the next tutorial. Goodbye.